Today's learning target, you will be able to find the missing side of a triangle using the Pythagorean Theorem, and you're going to demonstrate this to me by correctly finding three missing sides. As we look at the triangle, we know it's a right because it's got that square in the corner. That tells us that this is a 90-degree angle down here. The two that make the L shape are called the legs. And the longest side that is across from the right angle, you can almost think like the right angle is pointing at it, is called the hypotenuse. The Pythagorean Theorem relates these sides together, and we use the letters A, B, and C. A and B are interchangeable for the legs, but C has to be the hypotenuse, the longest side. The Pythagorean theorem is that the two legs squared and added together, a squared plus b squared, is equal to the hypotenuse squared, c squared. So now what we're going to do is we're going to take these numbers and plug them in. So my a is going to be 8. I still need that squared on there. My b is going to be the 3. I still need that square on there. And then I don't know what the c is. That's what I'm looking for. Squared means times itself, so this is 8 times 8. 8 times 8 is 64. 3 times 3 is 9. Next, I can add these together because they're on the same side with our plus sign. Okay, to get rid of a square, we want to do the opposite. The opposite of a square is a square root. So I want to see all this up to this point, and then we're going to put a square root on it. Whatever we do to one side, we have to do to both sides. Over here, the square and the square root are opposites of each other, so these two are going to cancel each other out. So we're just left with a c. Now, if it was a perfect square, we could just do this ourselves, but the square root of 73 is not. All the other square roots are going to be irrational numbers, which means they go on forever, they never end, they never repeat. So this is a suitable answer right here, but if we were to type it in, we can write down everything that shows up on the calculator. And again, this is rational, so it keeps going. So C is going to be about 8.5. Now, one thing I'd like you to do to check these answers is please make sure that your C is bigger than the other two. So the other two were 8 and 3. So our answer wants to be bigger than both 8 and 3, and 8.5 is bigger than both of those. Take a moment, please, and draw this triangle down. And then see if you can label the A, the B, and the C. So the longest side, the one across from the right angle, has to be my hypotenuse, my C. These two, it doesn't really matter which one you call A and B. So I'll call this one down here A, and I'll call this one B. Okay, so plugging into our a squared plus b squared equals c squared. A is 4. B is 9. And c, I don't know, so that's what I'm finding. So I can leave the letter c. 4 squared means 4 times 4. 4 times 4 is 16. 9 times 9 is 81. These two are on the same side with our plus sign, so we can just go right ahead and add those together. We want to get rid of a squared, so to do the opposite of a square is the square root. So we're going to just write that right on top of it. The square and the square root cancel each other out, leaving the c. And then I could leave square root of 97, but I could also type it into the calculator. it's rational, it keeps going on forever. So C is approximately 9.8. And then we just want to make sure, is that bigger than both 9 and 4? So yes, that's a good hypotenuse. These questions may tell you where to round. So they may say to the 10th and then it'd be 9.8. They may say to the hundredths, or they might not tell you at all, and you can choose to round where you think appropriate. Okay, take a moment and draw this one down. This one's going to be a little bit different. There's only 2 formats for these Pythagorean Theorem questions, and this is the second one. Okay, the 2 that make the L shape are the A and the B. The one across from the right angle that the right angle is pointing at, the longest one, has to be our C. We're putting it to the Pythagorean Theorem, which is a squared plus b squared equals c squared, where a and b are the legs. So I don't know the A. The A is going to stay. But I do know the B. The B is 3. And then our C I do know as well as our 7. So notice this time the 2 numbers are on opposite sides of the equal sign. So I'm going to draw my wall just to help us see that. 3 squared, or 3 times 3 is 9. 7 squared, 7 times 7 is 49. Okay, my goal is to get the letter by itself, the variable by itself. So I want to do the opposite of this plus 9 to remove it. So the opposite of plus 9 would be minusing 9 on both sides. 9 minus 9 is gone. 49 minus 9 is 40. But now we're back to the same spot we were on the last one. We want to get rid of the squared. So the opposite of a square is a square root. I have to put it on both sides. The square and the square root cancel each other out, leaving the A. And the square root of 40, I'll show you in a couple days how to simplify that down another way, but we could just type in the calculator as well. And if I were to round this off, let's say the 10th place, 6.3. Now, one thing that I've been forgetting to do in the last 2 problems is to use our units. These were both centimeters, so I know this length is also going to be centimeters. And then we want to check our answer. So our hypotenuse needs to be the longest side. So I need to make sure that the 7 is longer than both the 3 and the 6.3. So that does work. So this is the other format of the question. The first one was where you had A and B and you can just go ahead and add them. In this format, you have one number on each side of the equal sign, and then you're going to have to subtract. Okay, take a moment please and draw this one. See if you can label it with the A, the B, and the C. One across from the right angle, the longest side has to be my C, my A and my B. Doesn't really matter which one you call A and B, they're just the 2 legs on that right angle. So my A I'm going to call 3. The B I don't know, so that's staying. And the C is 12. Again, on this kind, the wall might help you. This is 3 times 3, which is 9. And 12 times 12, which is 144. I need to get the variable by itself, so I need to get rid of this plus 9. And when you want to get rid of something, you do the opposite. So the opposite of adding 9 would be subtracting 9 from both sides. 9 minus 9 disappears. The b squared is still there. 144 minus 9 is 135. To get rid of the squared, we do the opposite. So we square root that. Over here, we're also going to square root. Both sides do the same. Square and square root cancel each other out, leaving the b. And that should be fine, but let's type it in. This is everything that appears on the calculator. But to be a reasonable answer, I'd probably want to round it off. So let's call it 11.6. And then I want to use my units, the millimeters. And then I just want to check to make sure that both a and b are smaller than the 12. So 3 and 11.6 are both smaller than 12, so that checks. Okay, see what you can do with this one. See how far you can go by yourself. So first draw it, then I want you to label your A, B, C, then I want you to plug it into the right spots and see if you can go all the way down to solving it. The one we're looking for is the C. We had the A and the B, and again, it doesn't matter if you call the 7 the A and the 4 the B, that's fine. So So we get 4 squared is 16, 7 squared is 49. When you add them together, you get 65. We want to do the opposite of squaring. The opposite of squaring is square rooting, both sides. When we type it in, we get 8.06225577 and so on. So rounding off to the tens place, let's call that 8 point, and because the 6 is 5 or larger, I have to call it 1, using my units, centimeters. And then I just want to make sure that the C is larger than both the A and the B. So 8.1 is bigger than both the 4 and the 7. And hopefully this turning didn't challenge you. We're still looking for the L shape, so that real straight right angle there, those are our A and our B. And then the one across from the right angle is going to be our C. Okay, this time we have no units, and we have an X here. So you could use one of the letters, the A, B, or C, or you can go ahead and throw the X into our equation. It doesn't really matter. So why don't you go ahead and try getting our letters, A, B, C, plugging it in and solving it. Our 26 on the top here is going to be our C. It's our longest side, the hypotenuse, the A and the B. I chose to put the X in where the B was. Typing in 24 squared, 26 squared, I got these two answers. I want to get my variable by itself, so I'm doing the opposite of adding, which is subtracting the 576, and I get 100. So now the opposite of the square is the square root. The square and the square root cancel each other out, leaving the X. And over here, this one works out nice. The square root of 100, we could type it in, but hopefully you know what times itself gives you 100. That would be 10 times 10. I don't have units, so that is just my answer. I want to make sure that it is, this was our B. I want to make sure that our A and our B are both smaller than 26. So I had my 24 and my 10. So that works out well. Okay, let's try one with decimals here. One quick comment, I'll notice that both of these are to the 10th, so I would like to round this one to the 10th as well. Usually it's nice to keep them all the same, and we do have our units of centimeters. I don't have the right angle, but I'm going to assume that this one over here is that square with the 90 degrees. And they did tell you they'd like this to be A. So that means that this one then has to be your B, and this one over here has to be your C. The process with the decimals is going to be exactly the same. It's just that it looks a little uglier with those decimals in there. Putting in for the B the 4.2. Putting in for the C the 8.5. I'm just going to type it in. 4.2 squared is 4.2 times 4.2, which is 17.64. Likewise, 8.5 squared, typing it in, is 72.25. Opposite of adding would be subtracting. These two cancel out. Subtracting 72.25 minus 17.64 gives me 54.61. Opposite of square is the square root. Both sides. Square and square root cancel each other out, leaving the A. And then taking the square root of this, I'm going to write down everything I see, and then I'm going to come back and round. So since those are both to the tenths, I'd like to round this one to the tenth as well. I look one number behind it, because that is 5 or larger, I'm going to round up, 7.4, and then using my units of centimeters. Lastly, I just want to check to make sure it's reasonable. So if my hypotenuse is an 8.5, then 4.2 and 7.4 are both less than that.